Good to one and all.
आवाज मत करो बेटा.
After having a delicious and a heavy lunch, I think one must be getting sleepy. And I am very much thankful to the speakers of the morning. And also, I am very much thankful to my younger brother figure, Dr. Vastupati Shastri, who is also uh, the principal of the PMCOA Ratlam. It is my privilege to invite him as a keynote address speaker for the evening session. Before going to the presentation, I would like to tell all the audience who are sitting mode and off online mode also. He is one of the silent killer. He speaks less, but his words are very much worthy. He is a very good worker in terms of research and commitment are much very high. That is the reason why he has been selected for BHU also. A faculty from BHU, it is one of the legend university in the India, not only in India and also abroad, has come to Ratlam to, to serve for the poor people. If you are happen to come to know that, go through his biodata, which is also displayed in the website of the college, and you feel very much surprised and also proud to have such type of wonderful speaker, not only speaker, wonderful teacher and a researcher who is serving as a principal of the Ratlam College. I cordially welcome you, sir, and I hope your presentation will definitely enhance the not only our college students but also other youngsters of the research who are doing on the Indian traditional
Knowledge.
skills or whatever skills or traditional medicine or whatever it may be. सो इस भारतीय ज्ञान परंपरा का प्रकोष्ठ के तत्वाधान में हमारा महाविद्यालय आपको स्वागत करता है, अभिनंदन करता है सर. हम चाहते थे पहले आपको फिजिकली आपको स्वागत करने का मूड था, लेकिन आप because of some certain unavoidable circumstances you could not join in offline mode. So again, I welcome you, sir, and please I request you to go for your presentation.
Thank you, sir. Thank you. Thank you, Dr. Reddy. I'm opening my presentation. मिश्रा जी देखिए प्रेजेंटेशन मेरा चालू नहीं हो पा रहा है.
हाँ अभी तो नहीं हुआ सर.
एरर बता रहा है.
बट विजिबल अगर किसी को दिख रहा तो बताएं. बट अभी तो मुझे तो नहीं दिखाई दे रहा सर. यस 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 सर.
हाँ.
इट्स विजिबल नाउ सर.
Okay. So I am taking consideration of two things. One is mathematics and other is Ayurveda. The traditional knowledge system in mathematics was done very early stage at early times. The mathematical concept which is taken here, which I am discussing, that is arithmetic mean. Arithmetic mean is a simple formula which assigns weight to the formula. You can see here x bar equal to w1 x1 plus so on wn xn divided by w1 w2 wn. That is very simple formula, and we will see in this topic that how this weighted arithmetic mean was brilliantly used in earlier times in our Indian knowledge system. So I am going through quickly to the Indian knowledge system rather than going deep in the formula. So you can see here that the earlier mathematician which names is Brahmagupta 628 CE, Sridharacharya 750 CE, Madhavacharya 850 CE, Praduk Swami 864 CE, Bhaskaracharya 1150 CE. These all has done work in weighted arithmetic mean, and they have used in various variety of topics. So I'm skipping because time limit is a constraint to me. I'm starting from here. Tycho Brahe. Actually, the arithmetic mean has been used in various topics. Various topics means for finding quality of gold, for finding excavation problem, and also Tycho Brahe in 1946 to 16101. It has used arithmetic mean, and it has obtained the observation to the rounded value, and it has been used in geomagnetic studies. You can see here that the degree is 26 degree 0 minute and 30 second, and 26 minute 0 uh, 26 hour degree 0 minute and 27 second. So these all has been calculated using the formula which I have discussed, and the Tycho Brahe has used this formula in the geomagnetic studies. You can see here arithmetic mean in geomagnetic studies. In using that formula, what they have done, they have find the magnetic declination, the angle between the magnetic north and the true north. There are two different north. One is magnetic north and other is true north. So I think there are lesser person who are belonging to geomagnetic study. So I have shown one use of geomagnetic study using arithmetic mean. I am coming to the interesting one. Now, the important Brahmagupta has created formula of statistical weighted mean, arithmetic mean in excavation problem. Whenever we have to do excavation, how correctly it can be done. So, in the he has given one formula in Ganit Adhyay. The verse is 44, and the book's name is Brahma Spruta Siddhant, which has been published in 628 CE by Brahmagupta. So, what we see that the statistical formula has been developed after in the 15th and 16th century, but before that, the Brahmagupta has used the same formula by using the shloka. In a shloka, he has given that mukha means face, and then tulya means upper or top side, and he has given bhuja means side, and then he has ekagra means whole of the long side, which has to be subdivided, and hra means divided, and samarajju means the line of segment. So you can see the shloka that it has given mukhatulya bhuja ekagra hra and samarajju. So by using this formula, by using this shloka, he has created a formula. You can see. So if suppose the different lengths are L1, L2, Ln, and the deep depth is d1 d2 dn, because whenever you are doing excavation, in excavation the depth and length, there are two separate things. So if L1, L2, Ln are the length and D1, D2, Dn are the depth, then the mean can be defined as d bar equal to L1 D1 plus L2 D2 and Ln Dn, so on, divided by N1 N2 Ln. So you can see how this formula uses, and Brahmagupta has done excavation using the same formula. You can see the length here. Here is the length L1, this is L2 length, this is L3 length, this is L4 length, and so on. This is Ln length. And here the vertical D1, D2, Dn are the depth. So the mean depth of the excavation is computed by estimating the volume of the excavation. We can find what will be the volume, and Brahmagupta also has mentioned that the volume of excavated region is obtained as the area multiplied by its depth. And similarly, the Aryabhatta, after Brahmagupta, he has also done work in the book named Praduk Swami, titled Vasana Bhashya. This is Pradukta illustrative example, which has given this formula. And in this formula, he has described that a pool of water 30 cubits in length and 8 cubits in width comprises within its 5 portion of excavation, by which length is subdivided into 5 parts measuring 4, 5, 6, 7, 8 cubits, the corresponding depth measuring respectively 9, 7, 7, 3, 2 cubit. Say what is the mean of the excavation. So mean of the excavation will be 5 cubit. Means the same thing, he is multiplying L1 D1 plus L2 D2 plus L3 D3 and so on, L5 D5, which comes out to be 150 square cubit. And since total length is 30 cubit, so 150 divided by 30 cubit is 5 cubit. So you can see the same thing. The even example which has been taken is given in the form of shloka. And in that earlier days, using that shloka, the formulation was so simple and calculation as well. Now coming to next, Sridharacharya, he has used arithmetic mean in excavation problem using this shloka. So in his text of Trisaktika, Sridharacharya presents the following problem of mean depth of excavation of uniform length and depth, but variable width. Here width is variable. So he has given this shloka, and in an excavation of uneven width, whose width at 3 different places 3, 4, 5 cubits and depth of 8 cubit and length is 12 cubit, tell me the volume of excavation. This shloka describes the question in it also. So the translation of this shloka is, you can see, in an excavation of uneven width, whose width at three different places 3, 4, 5 cubits and depth is 8 cubit and length is 12 cubit, tell me the volume. He is asking through shloka. So solution again is 3 plus 4 plus 5 divided by 3, which is 4 cubit, and the estimated volume will be 12 into 4 into 8, 384 cubit. So in very early days, they were using the statistical formula which has been developed in 16th century. Again, we can see another example of Mahaviracharya. So Mahaviracharya has given also the formula for excavation, and in his written book of Ganit Sara Sangraha, chapter 7, verse 4, he has given the same thing, and he has considered excavation where the horizontal area are not constant. Moreover, even in any horizontal section and length and width are not constant. So Mahaviracharya applies a midpoint type rule. So he has taken T1, T2, Tn are the top lengths, and B1, B2, Bn are corresponding bottom length. Then the mean length is given by T1 plus B1 plus so on T1, Tn plus Bn divided by 2n. This different formula. This is not weighted mean formula because he has considered a midpoint type rule. So we can see here the T1, T2, Tn, which I have shown here. You can see again. If T1, T2, Tn are top length and B1, V2, Bn are corresponding bottom length, you can see here. T1, T2, Tn are top lengths, B1, B2, Bn are bottom length, then the formula will be T1 plus B1 plus T2 plus B2 plus so on Tn plus Bn divided by 2n. This will give the area, excavation area. So in the verse, Shloka, he has given the usual measure of a regular excavation is given by the product of its area and its depth. So he has taken, take the half of the sum of the top and bottom, divide by 2n. In this formula, he has given that take the half of the sum of the top and bottom and divide by the number of section, that is mean length respectively. Similarly, Bhaskaracharya has also given for excavation problem. So Bhaskaracharya, in his renowned book Leelavati, he has given the formula in the form of shlok. This can be translated as the width of a ditch is to be measured at several places. The mean width of a ditch is defined to be quotient of the sum of the width divided by the number of places. Likewise, the mean length and mean depth are determined. Then the estimated volume of the ditch will be the product of the estimated area and the mean depth. In means the same formula L1 D1 plus L2 D2 plus Ln D1 divided by L1 plus L2 plus Ln, yani weighted mean, he has given the same formula in form of shloka. In his next verse, Bhaskaracharya again given another formula of finding volume of irregular shapes. So in finding volume of irregular shape, he has given this verse. And I am translating this verse, taking measurement of curved sides of irregular ditches at 3 places. The lengths obtained are 10, 11, and 12 cubit, breadth 6, 5, and 7 cubit, and depth 2, 4, and 3 cubit. Then in this verse, he is asking, tell me the volume of a ditch in cubic. Prachami. Prach means ask me. So here is the figure. L1, L2, Ln are the width, are the length. W1, W2, Wn3 are the width. So how it is calculated? It is calculated as W1 plus W2 plus W3 divided by 3 and L bar L1 plus L2 plus L3 divided by 3. Then he will consider the depth. Then if D1, D2, D3 are depth, then D bar is D1 plus D2 plus D3 divided by 3. So how the excavation volume will be arrived? So the mean length of cubit is 11, mean breadth is 6, and the mean depth is 3. Then by Bhaskaracharya principle, the estimated volume is 198 cubit, means multiplying the length cubit, breadth cubit, and the depth cubit. So in his treatise, Ganit Kaumudi, Narayan Pandit also has made the similar statement as given by the Bhaskaracharya. Then there are another thing, law of large number, which I am not covering here. Then the seeds of calculus in arithmetic. The seed of calculus has also been given in our ancient literature. Avinash Sathe point out the idea of approaching the correct area or volume of a region given by increasing and subdivision of the region that is explicitly states by Ganesha is analogous to the idea of Riemann sum in integral calculus. Sathe also remarks that this idea of using separate means for the three dimension can be seen in light of mean value theorem of integral calculus. So we have seen the use in integral calculus. Now, Ratlam, as all of you know, is a city of gold. The purity of gold is very high in the city of Ratlam. So I am taking a problem of ancient India, how the purity of gold in allegation problem was computed. So the term Varna, Kasya, and Masa, these were ancient terms when the purity of gold were decided. The word fineness is used to indicate the proportion of pure precious metal in an alloy of the metal. The Sanskrit word varna, whose meanings include color, luster, glory, quality, etc., it is used in ancient Indian treatise to denote the fineness, purity of gold. The fineness of pure gold is defined to be 16 varna. If it is 16, that means it is 100% pure. Thus, a gold of one varna contain one part of pure gold and 15 part of impurities. A gold of two varna contains 2 part of pure gold and 14 part of impurity, and so on. If I reverse that, 15 part of pure gold, that means there is 15 varna. And if it is 15 varna, then there will be 1 part of impurity. So 16 varna makes at equals to 24 carat in the modern technology. Just as varna indicate the purity of gold, the term kasya usually means dimension, diminution, losses, etc., has been used in certain texts to indicate the deficiency. Deficiency means the proportion of impurities in a piece of gold. A gold of 1 kasya contain 1 part of impurity and 15 part of pure gold. A gold of 2 kasya contain 2 part of impurities and 14 part of pure gold, and so on. Thus, if a piece of gold is fineness varna and deficiency, say V varna and K kasya, then V plus K should be equal to 16. Because I have told earlier that there are only 16 varna. A traditional Indian unit for the weight of gold is masa, which is approximately equal to 0.97 gram. Some of the Sanskrit synonym for gold like hema, suvarna, kanaka, swarna are also used for the weight of a piece of gold. Further, some of these terms are also used as a specific unit for the weight of gold. For instance, a piece of gold of weight 16 masa is called suvarna. We should see here the amount of pure gold in a piece of gold of weight W unit and fineness V Varna is WV divided by 16 units. Now, allegation and arithmetic mean. One of the standard topic in ancient Indian arithmetic treatise is Misra ka Vyavhara. Misra means like in chemistry, we say Misra. So Misra ka Vyavhara, allegation. So mixture of anything. A central problem of allegation, any mixture, is the computation of the fineness of a piece of gold formed by combining several pieces of gold of different weights and purities. The formula for weighted mean arises very naturally in some of these problems of allegation. If n pieces of gold of fineness, V1, V2, Vn are Varna, and weights are W1, W2, Wn unit are combined, then we can very easily find the fineness of gold in resultant piece is V Varna. So V can be arrived as W1 V1 plus so on Wn Vn divided by W1 plus W2 plus Wn. Thus, V is literally the weighted arithmetic mean of the fineness of original piece, with the literal weight of the gold pieces playing the role of mathematical weight. So you can see that in ancient time, the formula for the mixture of gold were given, and all are very well known, know that from very ancient time, the uh, ornament, making of ornament and fineness of gold were depicted in the early, period of Buddha, in the period before Buddha, and so on. So now next is weighted arithmetic mean is in Bhaskali manuscript. So the Bhaskali has given the same problem of finding the kasya of gold in a mixture. So he has given the formula. And this formula, he says that having multiplied the weight of the pieces of gold with their kasya, let their sum be divided by the sum of weights of the pieces of gold. The result is the average kasya. So if n pieces of gold W1, W2, Wn units have respectively kasya K1, K2, Kn, then the average kasya is given as W1, K1 and so on Wn, Kn divided by W1, W2, Wn. So you can see very easily the students can center here. There are numerical example. Say that if n equal to 4 means pieces are 4, and the kasya is first kasya is k1 equal to 1, 2, 3, 4, and the weights are w1 is 1, 2, 3, 4. Therefore, the average kasya will be 3. Similarly, in the second example, if n equal to 4 and the weights are different, and the k1 is something in fraction, then the average kasya can be arrived by multiplying this. So we can see that in very earlier time, our Indian knowledge system was so brilliantly dealt that nowadays people are using machines to finding the purity of gold. But in earlier time, the people were very conveniently calculated the different what is the purity of gold and so on. So I think I have taken my time. मिश्रा जी,
यस सर।
अगर टाइम बचा है तो मैं और आगे कंटिन्यू करूं?
हाँ, देख लीजिए सर, अगर 2-3 मिनट में आप फिनिश कर पाते हैं तो।
ठीक है, ठीक है. So this was the Sridharacharya formulation, and the Sridharacharya formulation for the weighted mean in the mixture of means allegation, that he has given one shloka, the sum of the product of weight and fineness of gold divided by the sum of weight of gold shall become the fineness of the piece. So he has given in Pati Ganita book of Sridharacharya. And in the same Pati Ganita book, he has given one exercise in this formula. And in this formula, he has given that when gold pieces of fineness 12, 10, 11 Varna with respective weight 9, 5, 17 mass are combined, what will be the fineness of the produced gold? The question is written in the form of shloka. So the solution is that the product of the weight and the fineness of the gold pieces are 9 into 12, which is 108, 5 into 10, which is 50, 7 into 11, 187. The sum of these product is 345. The sum of weight is 31. So on division, the resultant fineness of the Varn is 11 is to 4 by 31. So I am quickly coming to, there are several other formula you can see. This formula, formula is given in the form of shlok. Even the problem is given in the form of shloka. So Mahaviracharya version of weighted arithmetic mean in the mixture problem. So Mahaviracharya has also given the formula. In the same way, Praduk Swami supplement, he has given uh, his commentary in Ganit Adhyay book of Brahma Sputa Siddhanta by Brahmagupta, that he has given this shlok and this shlok. And in this shlok, he says that taking the sum of the product of the fineness of weight of several pieces of gold, dividing by its fineness of the desired, gives the amount, dividing it by the sum of weights of the pieces of gold gives the fineness, means the refined gold. So you can see that several earlier mathematicians have given the different formula in the same problem. Like I have dealt with the excavation problem, and now I am dealing with the alligation, means mixture problem. In the same, you can see this is the seventh formula which is given by Bhaskaracharya. So lot of treasure is hidden in our ancient books, and the students should read these books because these has
इधर कैसे आ गए?
several hidden
अभी
uh,
कॉन्फ्रेंस चल रहा है. हाँ.
several hidden treasures. So thank you, Mishra ji. I'm completing my topic.
थैंक यू वेरी मच सर. आपने काफ़ी फंडामेंटल वे में मैथमेटिक्स को समझाया और यू डिस्क्राइब अबाउट द हाउ टू मीनिंग ऑफ द मीन और वेटेड मीन. किस तरह से हमारे इंडियन जो मैथमेटिशियन थे उन्होंने ये सारी चीज़ें जो अभी हम लोग 10th हाई स्कूल की क्लासेस में मैथमेटिक्स पढ़ाते हैं, प्रोबेबली किसी भी इंडियन मैथमेटिशियन का नाम नहीं दिखता किसी में, सिवाय कि एक श्रीधराचार्य जो मेथड है क्वाड्रेटिक इक्वेशन का जो हम सॉल्यूशन निकालते हैं, उसके अलावा 12th और 10th या नीचे तक की क्लासेस में कहीं भी मैथमेटिक्स का नाम नहीं है. लेकिन आपने बताया कि सारी चीज़ें, तो आपने खुद दिखाया भी, चीज़ें देखी, बट दे आर एग्जिस्ट इन द फॉर्म ऑफ श्लोका. अभी क्या है कि उन सारी चीज़ों को उस तरह से हमारी मॉडर्न लैंग्वेज में कन्वर्ट करके लिखा गया है. हमारी चीज़ें उस तरह से
नहीं, मैंने कन्वर्ट कर दिया है. मैंने सब आपको इसलिए सभी का इंग्लिश मीनिंग
जी सर,
और हिंदी में कन्वर्ट किया हुआ है.
जी सर. अच्छा, तो ये जो फॉर्मूले आपने कन्वर्ट किए हैं सर श्लोक
जी जी जी
गजब,
जी.
ग्रेट सर,
हाँ
ग्रेट सर, ग्रेट
हाँ
सर,
हाँ,
ग्रेट सर.
जी.
तो थैंक यू वेरी मच सर. इफ़ एनी ऑडियंस हैव क्वेरीज देन यू मे आस्क. काफ़ी इंटरेस्टिंग वे में सर ने समझाया चीज़ें. यस. सो थैंक यू वेरी मच सर. सर ये जो
थैंक यू.
अभी जो आपने बताया कि रतलाम में जो है ये गोल्ड के बारे में वहाँ पर ज़्यादा प्योरिटी मिलती है,
हाँ,
तो उसकी इम्प्योरिटी या प्योरिटी कौन सा एलिमेंट कितना मिला हुआ है वो सब भी निकाल सकते हैं हम इस तरह से।
बिल्कुल बिल्कुल, उसमें क्या है, जैसे हमने बताया कि 16 जो है, अर्लियर मैथमेटिशियन ने 16 का रूल दिया।
जी सर।
हम लोग 24 कैरेट की बात करते हैं,
जी जी जी।
वो 16 को शुद्ध मानते थे।
इसीलिए स्वर्ण
अगर
आया, आपने बताया स्वर्ण।
हाँ हाँ
जी
हाँ हाँ,
जी
उसी से स्वर्ण आया, 16 से ही।
जी सर जी।
जी जी जी।
पहली बार पता चला। थैंक यू वेरी मच सर।
थैंक यू थैंक यू
मैं
थैंक
हमारे महाविद्यालय के
थैंक
प्राचार्य महोदय से निवेदन करूंगा कि 2 शब्द सर भी बोलें सर के लिए, और फिर आगे के लिए
सर,
कार्रवाई बढ़ेगी।
thank you, Dr. Shastri sir, for joining with us,
यू।
and your innovative and explanatory and effective presentation really enriched our knowledge. मैंने पहली बार देखा था स्टैटिस्टिक्स को अपना ट्रेडिशनल नॉलेज के श्लोक से जोड़कर किस प्रकार अपना भारतीय जो उस समय के जो वैज्ञानिक काम करते थे. So this knowledge is to be preserved for the upcoming students, researcher actually. तो थैंक यू डॉक्टर साहब, आप ज्वाइन किया हमारा महाविद्यालय के लिए, हम तरफ से आपको धन्यवाद अर्पित करते हैं.